Hi everyone, in this video I am gonna walk you through about building a RAG agent. Okay, so why do we even need RAG agent and what is a RAG agent? RAG agent is basically Retrieval-Augmented Generation agent. Like basically, in machine learning, we know that an LLM is trained with a lot of training data set, right? A very huge amount of training data set. But suppose we want to know about there's a hospital, we want to know about their data and all. Specifically that, so that LLM is so not trained on that data set, or we want to know about some research paper that is not trend on the data. So basically what a RAG gives, it's like an extension to the LLM. Like it gives additional it adds additional information to the LLM, which helps us get better answers. Okay, so yeah, this is it. So how it does it, like yeah, so in what form of data we can give it, like a document, text, or anything we can provide it to the HTML. Suppose even say, let's our our RAG agent is trained on on a previous data, right? When you see like there is a ChatGPT 5.5, then you know that it is trained up until like May 2025, like right, I don't know the exact date. So let's suppose like it's like that. So it is trained, so it's don't have the data set regarding like these 6 years. And let's say for another example, let's say blockchain, like we know um, ChatGPT is not trained on the blockchain database. We know about the like the DeepSeek. It is heavily trained on blockchain, so we can query anything related to it from DeepSeek. But ChatGPT are not related. But ChatGPT gives better answer. So uh, so what we will do, we will plug this information into that. Like we will use some, what should I say, some article or something like that, and we can plug in as a extension, and we can gather information related to it. Yeah, okay, so let's so basically what it gives us, it gives very uh, it helps in getting a specialized answer, and timeless, like current like it helps in getting information related to the present, right? Okay, so how we are gonna do this? If it is a text, we can simply provide it directly. We don't need to do anything much about it, right? We can give the LLM directly, fit it into it, and we can say that give me answer based on that. Okay, so yeah, also one of the downside is that it has very less memory, so it keeps forgetting that, and there are hallucinations and all. So let's not go, we are not going to talk about that. We are going to stick to what we are building. So how this actually works? So basically a user enters their query, asks their query, it gives in it their query gets into the retrieval stage. Like it checks for the database for this similar data in the vector databases. It use the algorithm, and then it augments that, and then it generates the response. Okay, so we are gonna learn about all these steps, what it is. And before that, suppose there comes the query, like you give the PDF, right? You give the PDF to the PDF or URL or something. Like if it is a text, we can easily give it to the model, right? But when it comes to PDF or Word document or anything other like HTML, so we want like in structure. If we don't give the structure, then it may lose our basic meaning what it was, right? So it helps in getting that, it helps in preserving that, so we want that the meaning gets preserved. So we will we want that that LLM gets it in a very structured format. So for that we can use some parsers. So here is the ingestion stage. Okay, so data is loaded, data is loaded and split, data is loaded and then splitted, then embeddings are built, then it is stored in database. Like we know machines don't understand our, like it don't understand English, it only understand 0 1. So we will store it in a vector form, and which will help in retrieval. So now let's talk about, let's move forward. Yeah. Okay, so yeah, in JSON stage, like um, as I told you, the model, we give the document to the model, and then it is it recording? Yeah, it's recording. So I had forgot. Okay, so where are I? Yeah, ingestion. So we have provided the data to the agent, our PDF to the agent, but how it won't understand the PDF, so we will need to parse it, right? So this parsing step is known as parsing, and storing step is known as ingestion. So basically, so we can use very different types of parsers like PDF parsers and all, but we know in PDF parsers it won't give you extra, like there is a heading, there is some tables, there is everything, right? So it won't preserve, it won't keep it in that format. It will just take up all the text and it will put it directly, like when you copy something, like suppose ChatGPT give you something and then you shift Control plus C, it copies everything. But we know ChatGPT what gives, it gives in markdown format. You didn't got the exact markdown. Wouldn't it be better if you had got that markdown? You can do that by clicking on that copy button at the end of that response. Yeah, it gives that markdown. Okay. So we want something like we get the structured data which will help in getting our answer better. So for that we can use, we can of course implement it directly using Langchain. We will create that, split the test and do everything, but here I am gonna use the Dockling by IBM. There are various other options too, and what we are gonna use with the Dockling is that we will load the data and then parse the text out of it, and then we will chunk it. Okay, we will chunk it, and then we are gonna, we're gonna chunk it, and then we are gonna see what we are gonna do. Yeah, so there are two types of chunking: early chunking and late chunking. In early chunking, what happens is that we split segments. We takes a large document and basically what we takes a large document and we splits it a very fit size. Like suppose this is a very large document, then we will uh, take this one line and put it in a single chunk, then we will take another line and put it in similarly we will create cluster, a lot of chunk, okay, and then we will embed all of them in their individual clusters. But we, do you know, suppose there are two, suppose there are two, what should I say, two chunks that are related to each other, then how it is gonna No, so there I have given two examples. Suppose Kavya loves fast travel and she lives near Film City. When we created the embedding and then we went for we created the embedding and then we give it to the LLM. So do you think who is she? How it is gonna know who is she? It just put it in embedding. And so we didn't know who she is. It lost all his meaning. So for solving this problem, we just late chunking. What late chunking does actually is that it takes up the whole long document, it embeds it in the it first takes all of the large document and it embeds it at once. Suppose there is this whole of the page, okay, so it would take it at once and embed it, and then it will creates a lot of tokens of it, like it will divide it into tokens along with so it won't basically what should I say, it won't store the it in like text, basically it store in you can see store it into tokens like so which can help us in suppose there is two things which helps us in they are related to each other, so it helps us in preserving that relation. By tokens we know that this and these two sentences are related to each other, so that would be put there over here and then it is chunked and that tokens are chunked and keep on chunking, okay. So now for chunking we so this late chunking we are gonna use Jina V3, okay. It is a model which will take our whole document and then it will create chunk tokens and then it will create that chunk into uh, it will take that token and then create chunks and then it will create embeddings of that one and then it will use the Jina segmenter that will basically create structural boundaries, like it creates the boundary what is basically needed so that our meaning don't get lost, okay. So basically paragraph sentences or section, so it will create boundaries in such a way that related like necessary information is preserved, okay. So what happens after that, after that we are going to store it in our vector database, but wait a minute. Now after processing we want to go into summarizing, okay. So no, but suppose there is a very but we can do this for the smaller document like uh, yeah, like for smaller document we can do that. But suppose where we have very much large data, then how we are gonna search in it, like if we use this Jina model then it would be slow, right, like going through all the chunks one by one and then checking it would be very hectic job, right. So for the large documents we can use the RAPTOR model. So basically what it does is that it recursively embeds cluster and summarizes the text into a it basically creates a tree structure in a very nicer fashion which helps us in retrieval very fast. So how it does that, so basically whatever embeddings or chunk we have created previously, so it takes up all those chunks and put it on the leaf nodes, like whatever chunks we have. Suppose we have a chunk of what we did in the first one, or there is we have the thing like all of the chunk is used as a leaf layer, and then what is done is that it is clustered all the leaf. Suppose these two are leaf one, right? So it is clustered, so it is clustered, like a related leaf layers are clustered, and then put, then it is like we, yeah, so yeah, it is clustered. So basically it we are gonna chunk all the leaf nodes, all, basically all the, we are gonna embed all the leaf chunks, okay, whether it is from the Dockling one or Jina V3 one, into a 1024 dimensional vector. But you know the 1024 dimension is lot big, so for that we, for reducing that dimension, we are gonna use this UMAP model, which will reduce the dimension of that one. It is a very super model while preserving the relationship, like it will preserve the relationship of the original data and still will reduce the dimension, and it will create it in a very like what's the 3D 4D dimension, which will looks very nice in the graph form, you know. We can visualize it using the visualizer also. So I do it because I have to, and there is a, then we will use that and cluster that. So we can cluster this using the HDBSCAN, with which will also have some noise, like suppose there are some data which is not related to anything, then it will also create that nodes which are not connected to anything, and we can also use that one whenever we are searching. How we are gonna search, we will see later on, and after that we will put it in the Gemini or whatever model we are using, we will give it to that, and we will suppose we have, suppose we have two leaf nodes. Suppose we have this one leaf node and this one leaf node, okay, this one leaf node. So we have created a cluster of these three, and then we will give to the Gemini and ask to summarize. If there is a relationship, so we will give it to summarize the, and using that we will create another node at upper level, and with the same data, like what the Gemini give us, that data we are gonna use it uh, to for the next step, like for that what should I say, for the next step, like we will use it as node and another cluster as node, and then we will keep on summarizing it. We will do it recursively and keep on doing it until we reach at the top of the model. There you can see a visualization of it too. You can will keep on doing it till we are left with one node, okay. So here is what I have said. पहले first all the leaf nodes are chunked, then it's there embedded into a 1024 dimensional vector, then the dimension is reduced using UMAP, then the cluster is created, then Gemini summarizes all of them, and we are gonna do it recursively till we are left with only one of these. Then what we are gonna do, then we are gonna store it in the, then we are gonna store all of these, everyone, all these, every node of it in a vector database, like I am using here pg database, pg postgres, yeah, pg. Okay, so how now in data is stored, now how we are gonna retrieve it, okay. So we are not gonna traverse this from top to bottom, like we are gonna search here, does our query match, like query comes from what is Google, so we are gonna use personality search, and we are gonna see the matches, like what which of the embedding matches to our query, whatever person it is, whatever will match near to that, like whatever has near to 1, it means it has the uh, higher match. So we will pick that one, like out of the result we can pick like top 50, top 20, whatever you are using. We will see also what we are doing, where we are ranking all of these searches. So basically what we are going to do, we are gonna put all of that, flatten all those nodes, and we are gonna put all of those nodes what we have created in the last step, these all nodes, into the Postgres database, and we are gonna search all of them at once, like all of these levels at once, and so that we can have a very bigger picture, also the details, like if we search it to like all of them, so we will see that it matches here, then it matches here, then it matches here. So we will know that this node contains what we are gonna we want, then this also contains, then this also contains. So this is how we are gonna do it, and then we can re-rank all of these. um, we will talk about this later, like re-ranking and all. So basically we will use the BM25 model. So for yeah, we are using yeah, BM25 model for getting the exact matches of for keywords, like we are using the other one like Raptor for the semantic analysis, right? But it will search like is this has similar meaning, does it has similar meaning, so it is based on that, right? But if you want to search a keyword, so then going through all of them is a very hectic process, like we are gonna match it. So for that we have a BM25 model we can use, which is best we use, which is basically if developed for this purpose, which helps us in finding the similar keyword. Okay, and then what we can do, we can uh, use both of them, like the what we result we have got from that Raptor, and then BM25, all of these, like keyword search and the vector search, and we can retrieve rank, like we are gonna rank it, all of those results we are gonna rank it, like suppose we are gonna take top 20 or top 50, so we can gonna rank it, right? Then again we are gonna use the Jina Reranker, which will again find out of that one. So suppose we are having like best 20 results, right? So we are gonna use the Jina Reranker. It is a very efficient model which will rank them based on like what are similar to, very similar to this one. So it will do that, and then we will pass it okay. So basically out of the that 21 we will get top 5 or 2. So it basically helps us in narrowing our options. Yeah, narrowing option, we are using these rankers so that we our search results get narrowed down. Okay, so that we can have a very clear picture of our solution. Then that narrowed what should I, that narrow search we are gonna fit it to the LLM, that this have our this embedding matches our uh, query. So I'm gonna give you fitted with you that information, and we will give query, and then our LLM will give very good result, better result than the previous one. Okay, so this is the flow that I have already talked about, and then what? Yeah, then LLM will take and give the answer back to us. Yeah, so I think that is it. And you can also, so we are not just doing the PDF chunking, we are also using the image chunking. We will take an image and we can use the Gemini vision model, which will create the chunks. And for you RL, we are using the CIO model. For code, we are logical block, and then we will put that into the raw chunks using the doc. We will take that raw chunks. We will use the lead chunking using the Jina V3 model, and then we will use that RAPTOR tree builder that will first reduce the dimension of 1024 pixel 1024 dimensional vector into very 2 to 3 dimensional vector, I would say. Okay, then we will do soft clustering, like we would cluster the data basically based on something like summarize the data, whatever would match. Based on that, we would keep on clustering, summarize the spread, yeah, then summarize and recurse until we get to the root. After this completed, then we'll store it. Then we will query. Then user will query give our question. So this is another pipeline. So we will first do the vector search using the cosine similarity, and then we will also use BM25, which will search the common keywords, like common keyword or similar keywords, and then we will put all of these results in the RRR fusion, which will give like top results, and then we will put it in the Jina Reranker, which will give the top of the top results, and then we are gonna give it to the Gemini. Then Gemini will process our data perfectly, and I can also show you what the uh, URL points I am using. Basically, it doesn't matter. I don't think I need to tell you about this one. I have used the Prometheus and Grafana for logging. I don't think it needs to be talked about. And all of this here, you can read the article I have. I'm gonna post it here. Okay, so that's it. Thank you.